In this lesson, we're going to look at the factor theorem. Now, this theorem, the factor theorem, allows you to determine whether a polynomial has x minus c as a factor. Okay, so let's remind ourselves what we mean by a factor. So let's review the idea of factors. So for example, if we look at 8, we know is 2 times 4, right? So that means that if 8 equals 2 times 4, then that means that 2 is a factor of 8. So this means 2 is a factor of 8, which also means 4 is a factor of 8. Is a factor of 8. And so we could also say, well, I know that 8 is also 8 times 1, right? So that also means that 8 is a factor of 8 and 1 is a factor of 8. So also 8 is a factor of 8 and 1 is a factor of 8. And we could generalize this in terms of polynomials as well. So we know that this polynomial 2x squared plus 5x minus 12, when I factor this, then this is going to be x plus 4 times 2x minus 3. So when we factor polynomials in a previous course and also in some of our lessons in this course, we wrote this polynomial as a product, in this case, of two factors. So these are your factors. So this is a factor and this is a factor. All right, so just like 2 times 4 was equal to 8, this is a factor, this is a factor. This is a factor, this is a factor. So remember, when you factor, you write this polynomial as a product of factors. And so these are your factors. One of the other things I want to remind you is this. If we say that 2 is a factor of 8, or 4 is a factor of 8, or 8 is a factor of 8, and so on, it also means this. It means that if I take 8 and divide it by 2, I get 4. Remainder 0. So notice the remainder is 0, right? If I take 8 divided by 4, I get 2 with remainder of 0. So the idea also applies with polynomials. If I take this polynomial 2x squared plus 5x minus 12 and I divide it by x plus 4, what do we get? What remainder do we get is the idea. Okay, so what remainder do we obtain? So that's what I want to talk about for right now in terms of this factor theorem, and that's going to help us with this factor theorem. What is the factor theorem? Okay, so again, going back to this idea that if I take 8 divided by 2, so notice that 8 is divisible by 2 because the remainder is 0. 8 is divisible by 4 because the remainder is 0. So 2x squared plus 5x minus 12 must be divisible by x plus 4 because x plus 4 is a factor, right? So if that's the case, what do you think the remainder is? Well, the remainder should be the same as these, right? The remainder should be 0. The remainder should be 0. All right, so let's talk about that. Okay, so we're going to check this using synthetic division. Now remember, whenever we divide by x minus c, so if I have a polynomial f of x, I'm dividing it by x minus c, then we can use synthetic division. Use synthetic division. Okay, so as long as the divisor is x minus c, we can use synthetic division, and this is. Now you have to be careful because remember it's got to be x minus c. So when we did our problems with synthetic division, you know that you have to rewrite this as this x plus 4. So you have to rewrite this. I'm going to go ahead and write it like this. 2x squared plus 5x minus 12 divided by x minus a negative 4. So c in this case is negative 4. So let's go ahead and see what the remainder is. So we have negative 4, and I'm going to write out the coefficients of my dividend. Notice there are no missing terms, and it's already in descending order. So we have 2, 5, negative 12. So you bring on the 2. Negative 4 times 2 is negative 8. You add 5 plus negative 8 is negative 3. We multiply. Negative 4 times negative 3 is a positive 12. We add, we get 0. Okay? And so what I want you to notice, see this right here? So first of all, the remainder is 0. So since the remainder is 0, okay, then x plus 4 is a factor of 2x squared plus 5x minus 12. Okay, so this brings us back to the remainder theorem. So remember the remainder theorem said this. So let's remind ourselves what the remainder theorem says. The remainder theorem said, let me go ahead and write it like this first. So the remainder theorem stated this. If you have a polynomial divided by x minus c, okay, have a polynomial divided by x minus c, then the remainder, whatever remainder we got when we did synthetic division, whatever remainder you would get if you use synthetic division, then the remainder is just f of c, which equals r. So the remainder, whatever remainder you got, would be f of c. So whatever c is here, f of c would be your remainder. Okay? So then that brings us back to this, what we were talking about. See this right here? So f of x is being divided by x plus 4. Okay? So what that means then is this. I'm going to go back and kind of say this. So from our previous example, okay, so where we had 2x squared plus 5x minus 12 divided by x plus 4, then we saw the remainder 0, right? So here's your c right here. So we know that f of negative 4 is equal to 0 because that's our remainder. So our remainder is 0. Okay? All right, now let's continue our discussion about this. All right, so we know that when 2x squared plus 5x minus 12 is being divided by x plus 4, and notice this is that form x minus c, our coefficient of x is 1, we see that f of negative 4 is equal to 0. So when we did this work, we got a remainder of 0. So negative 4, 0, remainder 0. Okay? So what that means is this. So that means several things. So if since f of negative 4 is equal to 0, then that means that x plus 4 is a factor of 2x squared plus 5x minus 12. And we know that's true because when we factored it, those were your factors. Okay? So notice f of negative 4 was equal to 0. So that means that x plus 4 is a factor. So that's part of our factor theorem. All right, so the factor theorem basically says this. Okay, so here's our factor theorem. And there are going to be two parts to it. Okay, the first part says this. We're going to let f of x equal a polynomial, so be a polynomial. Okay, then part A, if f of c is equal to 0, just like we saw here. F of negative 4 is equal to 0. So if f of c is equal to 0, then x minus c is a factor of f of x. And that's what we saw. So since f of negative 4 is equal to 0, then that means that x plus 4 is a factor of 2x squared plus 5x minus 12. And we know that's true because at the beginning we had factored this polynomial. And these are our two factors. Now I can use synthetic division on this one, but I cannot use it on this one because that coefficient is not 1. Okay, now the other thing is this. Okay, we can kind of go reverse here. So if x plus 4 is a factor of this polynomial and I use synthetic division, then I better get a remainder of what? I better get a remainder of 0. So the second part says this: if x minus c is a factor of f of x, then f of c must equal 0. Okay? So that's the factor theorem. So the factor theorem has two parts. If you're told that f of c is equal to 0, then that means that x minus c is a factor. If you're told that x minus c is a factor, then f of c must equal 0. Okay, so that's where you're basically going both ways. Now, sometimes it can be written like this. So sometimes the factor theorem looks like this. They'll put these two together to make it look like this. So look carefully. So sometimes we can write the factor theorem as follows. Okay, so here we go. So this is what I want to write. A polynomial f of x has a factor x minus c if and only if f of c is equal to 0. So that if and only if basically says that you can go both ways like we did here. So if f of c is equal to 0, then x minus c is a factor. If x minus c is a factor, then x plus f of c must equal 0, and that's what this part says. So if x minus c is a factor, then f of c must equal 0. Then you can go backwards. If f of c is equal to 0, then x minus c must be a factor. Okay? All right, so that is a factor theorem. Now, how do we use it? Let's look at some examples. Okay, so number one, use the factor theorem to determine if the first polynomial is a factor of the second polynomial. All right, so notice this is our first polynomial, this is our second polynomial. So since the first polynomial, this right here, and that's going to be our divisor, is a linear and has a coefficient of 1 for x, then I can use synthetic division. So according to the factor theorem, remember the factor theorem, which remember basically had two parts. So the first part said if f of c is equal to 0, then x minus c is a factor of f of x. If x minus c is a factor of f of x, then f of c must be 0. Okay. All right. So if I want to use the factor theorem to determine if the first polynomial is a factor of the second polynomial, I've got to find, and remember this is x plus 3, so you got to remember this is also written as x minus a negative c. I'm sorry, negative 3, excuse me, negative 3. So this right here is your c. So I have to find f of negative 3. Okay, so I'm going to go ahead and use synthetic division. So let's see what this says. So negative 3, then we put the coefficients of our polynomial. It is in descending order, and it looks like I don't have any missing terms. X to the fourth, x cubed, x squared, x, and our constant. So I'm just going to write the coefficients. 2, 7, negative 4, negative 27, negative 18. All right, now I may need a calculator to help me with this. All right, so bring on the 2, and then we multiply. Negative 3 times 2 is a negative 6. Then we add, we get 7, negative 6 is 1. Multiply, negative 3 times 1 is negative 3. Add, negative 4 and negative 3 is negative 7. Multiply, negative 3 times negative 21 is, times negative 7 is a positive 21. When we add negative 27 plus 21, we get negative 6. Then we multiply, negative 3 times negative 6 is a positive 18, and when we add, we get 0. So what we found is this: f of negative 3 is equal to 0, right? So the remainder is 0. So this means that x plus 3 is a factor of 2x to the 4th plus 7x cubed minus 4x squared minus 27x minus 18. Okay? And that's all you do. You just use synthetic division and see if you get a remainder of 0. All right, so that's number 1. All right, now number 2, the directions says it this way. So sometimes the directions will be a little bit different than other directions, but they mean the same thing. So number 2, use the factor theorem to determine if the linear polynomial, so notice that this was the linear polynomial, and the coefficient of x is 1, is a factor of the second polynomial. All right, so here's our linear polynomial. So remember that x minus c. So I can rewrite this as x minus a negative 2. So this is your c right here. So c is negative 2. So x plus 2, so according to the factor theorem, x plus 2 is a factor of this if the remainder is 0. All right, so let's go ahead and use synthetic division. So we have negative 2. And then let's see, it looks like I'm not missing any terms, and it's already in descending order. So I get coefficients here is 1. Coefficient of x squared is also 1. The coefficient of x negative 5. And the constant is 3. All right, so bring down the 1. Negative 2 times 1 is negative 2. When we add, 1 and negative 2 is a negative 1. Multiply, negative 2 times negative 1 is a positive 2. We add, negative 5 plus 2 is negative 3. Multiply, negative 2 times negative 3 is a positive 6. We add, we get 9. So the remainder is 9. All right, so that means that f of negative 2 is equal to 9, right? So that means that x plus 2 is not a factor. So x plus 2 is not a factor of x cubed plus x squared minus 5x plus 3, since f of negative 2 is equal to 9 and not 0. Okay, so remember the remainder must be 0. Okay, all right, so that was number 2. So remember, this is a factor of this if the remainder is 0. The remainder is 0. Okay, so number 3, use the factor theorem to determine if the second polynomial is a factor of the first polynomial. All right, so this is our first, this is our second. So is this x minus 2 a factor of this? All right, so we're going to go ahead and use synthetic division to determine that. So according to the factor theorem, if the remainder is 0, then this is a factor of this. All right, so we got to determine c though. So notice this is the form x minus c. So c here is equal to 2. So we get 2, and then let's see, I am missing a term here. So I'm missing the x term, so I'm going to need to put a 0. So I have 4 in descending order, negative 3, then 0, and then negative 2. All right, so bring down the 4, then multiply. 2 times 4 is 8. When I add, negative 3 plus 8 is 5. Multiply, I get 10. 2 times 5 is 10. Add, I get 10. Multiply, I get 20. And when I add, I get 18. Now remember, that's your remainder. Okay, that's a remainder. Since the remainder is not 0, then x minus 2 is not a factor of this polynomial. So since the remainder is not 0, since the remainder is not 0, then x minus 2 is not a factor, of 4x cubed minus 3x squared minus 2. All right, so this is your work, and that's your answer. So this is your work. Okay, keep that in mind. That's your work, and this is your answer. Okay, so you both show the work and the answer. All right. Okay, so that's number 3. Okay, so number 4 is written this way. You're told that f of x is x to the 5th minus 3x cubed plus 2x minus 8, and d of x is x minus 4. And the question is, determine whether d of x is a factor of f of x. So if you want to rewrite this, you can say this. You can say determine if, and d of x is x minus 4, so determine if x minus 4 is a factor of, and then f of x is this. So it's a factor of x to the 5th minus 3x cubed plus 2x minus 8. And so since this is a linear factor and it has x has a coefficient of 1, we can use synthetic division. So c in this case is 4. So remember it's x minus c, so c is 4. So we have 4, and then we have, notice I am missing an x to the 4th, and I have everything else. Oh, I'm missing an x squared as well. So I'm missing 2 terms here. So I have the coefficient of x to the 5th is 1. The coefficient of x to the 4th is 0. Coefficient of x cubed is a negative 3. Coefficient of x squared is 0. Coefficient of x is 2. And then our constant's negative 8. All right, so let's use synthetic division. Bring down the 1. 4 times 1 is 4. Add, we get 4. 4 times 4 is 16. Add, negative 3 plus 16 is 13. And it looks like we need a calculator for some of this. 4 times 13, if you can't do this quickly in your head, use your calculator. We get 52. Then we add, we get 52. Multiply 4 times 52 will give us, looks like 208. We add, we get 210, right? 2 plus 2 8s do 10. Multiply 4 times 210, so 210 times 4 gives us 840. 840. And then when we add negative 8 plus 840 will give us 832. Okay, so the remainder, so this is our remainder. So remember, if the remainder is not 0, then that means that x minus 4 is not a factor of this polynomial. All right, so since the remainder is not 0, all right, so since the remainder is not 0, then this means that x minus 4 is not a factor of x to the 5th minus 3x cubed plus 2x minus 8. All right, and we could have also said this. We could have also said since the remainder, so this is our work though, okay? This is your work right here. All right, and this is your answer. So you could have said this, or you could have said since the remainder is not 0. And remember in our problem we used d of x and f of x, we could just say this. So since the remainder is not 0, then d of x is not a factor of f of x. Okay? All right, so this will bring us to the end of this part of the lesson of the factor theorem. So remember the factor theorem had 2 parts. And for the most part, we just use this right here. This right here. So if If the remainder is 0, then x minus c is a factor. If the remainder is not 0, then x minus c is not a factor. So that's all we used. Okay. Now there is another part to this. There's another part to this that says that if f of c is equal to 0, then x minus c is a factor. And so one of the things we're gonna talk about in the next part of our lesson using the factor theorem is the idea of zeros. So that's gonna be the next part. The next part is gonna talk about the idea of a zero. Okay? All right, so that is the end of this lesson.